So this is oral exam 2. Here's the statement, here's my signature. The equation is r equals 2 minus the sine of theta over 3. I made a table, so starting at theta equals 0, then I did intervals of pi over 2, so theta equals 0, theta equals pi over 2. I kept going up until I got to 12 pi over 2, which is equal to 6 pi. So at theta equals 0, r will be equal to 2. At theta equals pi over 2, r will be equal to 1.5. So starting off at theta equals 0, that'll be here. R will be equal to 2. Okay, then at pi over 2, r will be equal to 1.5. At pi, r will be equal to 2 minus the square root of 3 over 2, which is a little greater than 1. Then at 3 pi over 2, r will be equal to 1. At 2 pi, r will be equal to 2 minus the square root of 3 over 2, which is just greater than 1. And then we have to keep going until we make it back to this point here. So keep going, 5 pi over 2, r will be equal to 1.5. Then we go to 6 pi over 2, r is equal to 2. Then we keep going, r will be equal to 2.5. Then r will be equal to 2 plus the square root of 3 over 2, which is slightly less than 3. Then it'll be equal to 3. Then it'll be equal to 2 plus the square root of 3 over 2, which is slightly less than 3. Back to 2.5, back to 2. So when theta equals 6 pi, r will equal 2. So we just created our loop, and then it'll keep making the same loop. So we need to find the area of this section here. So when theta is equal to pi over 2, which is this point here, r will be equal to 1.5, and then we need to get back to this point. So theta equals pi, theta equals 3 pi over 2, theta equals 2 pi, and then back to 5 pi over 2. So when we are trying to find the area and we're doing the integral, we'll be going from pi over 2 to 5 pi over 2. So to find the area under the curve, we use this integral here. So the integral from a to b of 1/2 r squared d theta. So the integral from pi over 2 to 5 pi over 2 of 1/2 r, this is the equation, squared d theta. So I expanded everything, and then I wanted to get rid of this square here, so I used one of the trig identities, and this will be equal to 1/2 times 1 minus cosine of 2 theta over 3. So I simplified everything here, took the integral. I'll get this here, evaluated from pi over 2 to 5 pi over 2, plugged it in, simplified everything more, and I eventually got the final answer of 9 pi over 2 minus 45 times the square root of 3 over 8.